Hello, Math 7 students. This is Utah Middle School Math Project 1.1b, Probability Race to the Top. For this experiment, we are going to be going to the horse races. In order to do that, you will need a pair of dice. So the way this works, you need to first start by predicting which horse you think is going to win the race. What that really means is you're predicting which numbers 2 through 12 are going to be rolled the most times when we roll a pair of dice 30 times. So the way this works is I will be rolling the dice, adding the two dice together, and then whatever that number is, I will fill in one of those boxes. So stop now, predict which horse you think is going to win, which horse do you want to win, and then we will proceed with the experiment. So to roll the dice, that time I got a 6 and a 4. 6 plus 4 is 10, so I will fill in just one space. That counts as 1. Now let's do it again. 1 and a 5, 1 plus 5 is 6, so I will fill in just one space. This now, because I have two spaces filled in, this signifies that I have done this experiment 2 times, and we can repeat this process. A 3 and a 4 is 7, so I will fill in the 7. And again, you will repeat this until you have 30 total rolls having your own data, which will be different than my data. Pause the video until you get this done. Okay, here is the data for my own experiment. You can see that the horse that won in my experiment it was a tie, I guess, between 7 and 8. They both had the most rolls of 5 rolls for both 7 and 8. And I'm going to need some help from my students in class to help calculate the probability of each one of these. So probability of 2, I can see that I rolled that 1 out of 30 times, but what I need help with is calculating what that is as a decimal. Thank you, Liv. 0.3, and that 3 is repeating? Just the 3, or is it the 0.3? Okay, thank you. Probability of 3, there was 3 out of 30. That one I can do on my own. 3 out of 30 is 0.1 or 1/10. 4, that was 2 out of 30. I know that simplifies to 1/15, but I don't have that decimal memorized. Thank you, Trace. On the 6? Okay, thank you. Same thing for the probability of 5. That was a 2 out of 30, or 0.06 repeating, with the 6 repeating. 6 was another 3 out of 30, or 0.10 and 1/10. 7 is 5/30, which I know simplifies to 1/6, and I believe that that is 0.16 repeating. Yeah. Same thing for 8, 5 out of 30, or 0.16 over bar with just the 6 repeating. 9, we've seen before. 9 was 4/30. No, we didn't see 4/30 yet, did we? Okay, 4/30, which, Joshua? Over bar on the 3, thank you. Probability of 10 was the same thing, 4 out of 30. Or 0.13 over bar on the 3. 11 was 1/30. We did see that before, 0.03 over bar. And probability of 12 was a 0 out of 30. I can calculate that one in my head. Okay, now we want to list which horse won for each group in the class. For me, it was 7 and 8, so I will list both of them. So if you have a tie, you can call out too. Let's start with Zuri's group. Which horse won for your group? Won for your group. A 3-way tie. Okay. Sophie. 8. And Jasmine. 6 and 7, 2-way tie. Alexis. 6. Gideon. 7. Cambria. 7 and 8, 2-way tie. Joshua. 6. And Dylan. 7. All right. Which horse won most often? Let's see. We've got a 7, 7, 7, 5. 6 of them were 7s, so 6, 7 won 6 times. Which other one did we see a lot? 8, 1, 2, 3, 4, but that only happened 4 times. 6 happened 3 times. So which horse won the most often? that 7 won the most often. So now this is the part that takes a minute. We need to create a class histogram. So the first thing that I'm going to do is I'm going to pause the recording while I collect the data from everybody's groups. We don't need to record all of that. And then we will create that histogram that actually shows that. But we're going to pause the recording as we collect all that data first. All right, here is the data from everybody in the class. All together, everybody in the class, we rolled 2 6 times, 3 18 times, etc. So based on this, in order for us to see all the information, we have to scale by 5. So each one of these represents 5. So coloring in 5 and just a hair above to be 6. So it's not going to be perfect by any means, but we're going to do the best that we can. 18, I'm going to color in 3 full boxes. And more than halfway up into the next one. I'm letting my OCD get to me, so I apologize in advance. 4, 25, 26, 27, just less than that halfway. 21 is just a hair over the 20. 33, a little bit more than halfway, between 30 and 35. 47 is all the way up here. 37. 28. 23. 17 and 8. All right, and now I'm going to pause while I actually fill that in. Okay, and here is our completed class histogram. Which horse won the most often for everybody? Based on this, which one is the clear winner? 7. Why? Why is 7 the winner? Discuss with your group. Some students already know, some students predicted accurately, but please turn and talk to your groups. Why is 7 the winner here? With your groups, ready, set, go. Okay, and now come back to me and let's discuss on the video. Share your thoughts with the recording, please. Why? Why is 7 happening the most often? Grant? Yeah, there's multiple ways to get 7. Any other thoughts on that? Okay, we're going to talk about that a little bit more in the next questions. Is this game fair? Not really. Why isn't it fair? Talk with your groups about why it's not fair. Okay, and now come back and tell me. I will say that there was a comment that I heard that said it's just a game of chance, and so that's why it's not fair. But let's go to an example of a fair game. What if we flip a coin? If we flip a coin, 50% chance that it's going to be heads and 50% chance that it's going to be tails, would that be a fair game? That's still just a game of chance. Would it still be a fair game? Is it more fair than this game? Why? Why is this game not fair? Oren. Correct. To get a 2, we can only get it one way. To get a 10, we can get it multiple ways, exactly. And so there are fewer ways to get a 2 than a 7. We'll just keep it simple. We don't have to list every single example. So the next thing that we're going to discuss, you have a lot of options here. What we are going to do is we are going to create a probability model. You need to understand what that means first. A probability model is a way that we can identify the probability, the theoretical probability, because we know our experimental probability, but it's a way for us to identify the theoretical probability of each one of these options. But we can't truly identify what that theoretical probability is until we list every single option. So the first thing that I want you to understand is there is a difference between rolling a 3 when the first die is a 2 and the second die is a 1 versus the second die being a 2 and the first die being a 1. So that's why we have different ways of creating this probability model, different ways of modeling these different outcomes. It's because it can really be a mind trick. So one of the ways is, let's list what we could have rolled for the first die. For the first die, we could have rolled, and I am going to color code, so it's going to take me a little bit of time. We could have rolled a 1, and the second die, we could have rolled a 1. Do you see how this is kind of the intersection of the two? The first die could have been a 2, so that's why a 2 is listed here. And the second die could have still been a 1. The next option is that first die, instead of being a 1 or a 2, it could have been a 3. All while that second die is still a 1. Do you see how we're organizing this data here? That is one way. I'm going to give you a few seconds to finish organizing that. I'm going to pause the recording and also complete the table, but it can be, again, really boring and tedious to watch me do it, so we're going to pause the recording as you do it on your own. All right. How many different ways are there to roll the dice? How many different combinations? Liv? 36, exactly. There's 36 different ways. So now when we're trying to calculate the theoretical probability, we know that however many times we can roll a 1, or a 2, excuse me, would happen out of 36 total times. So our theoretical probability is going to be out of 36. It says explain the system used. Well, this is what we used. We've calculated the first die, second die, all the different combinations. Another way that you can do it, and I like this because this is going to match with our histogram, but we can also pull that data from here. How many ways were there to roll a 2? There was just one combination, right? We roll a 1 and a 1, and that's it. How many ways were there to roll a 3? Let's see, 2 plus 1. 1 plus 2, those are the only ways that we can roll a 3, so that's why those are listed here, 1, 2, or a 2, 1. 4, how many different ways are there to roll a 4? 3 and 1 add to 4, 2 and 2 add to 4, and 1 and 3 will add to 4. So we can list that as well. 3, 1, 2, 2, and 1, 3. Let's continue taking this information from this and plugging it into here, and you're going to see something interesting happening. How many ways are there to roll a 5? Let's see, 4 plus 1 is 5, 3 plus 2 is 5, which is different than 2 plus 3 is 5, and 1 plus 4 is 5. So let's list those. 4, 1, 3, 2, 2, 3, and 1, 4. Again, I'm going to pause the recording as we take our data from here and put it up here, just so that we don't have to listen to that tediousness. Pause the recording as you do it yourself. All right, now here this is filled out. Doesn't this almost resemble our histogram that we saw as our whole class? We're seeing a peak at 7, we're seeing some low areas at 2 and 12, and it makes sense when you have it listed this way. How many different ways are there to roll a 2? Just one. One out of how many different possibilities? 1 out of 36. How many ways are there to roll a 7? 1, 2, 3, 4, 5, 6 different possibilities out of 36, which makes sense. Why 7 appeared to be so high when there were 6 different possibilities. So we have to finish this lesson up because we are running short on time. Your homework at the end of this video, if you have time, you can do it in class but I want you to find the theoretical probability for each of these outcomes. So we'll start with the probability of 2. Once again, we can see here is only one way to roll a 2. Here, there's only one way to roll a 2, and that is 1 out of 36. You'll need to convert that to a percent. Let's move on to the 7. There were, as we called already, 1, 2, 3, 4, 5, 6 out of 36 ways. 6 out of 36 does simplify. So 6 out of 36 simplifies to 1/6. Let's list that as a percentage as well. So finish that up for homework, and we will pick up right where we left off tomorrow in class. Thanks for watching. We'll see you next time.